topic of this video is building quadratic models from verbal descriptions, geometric models. Let's look at a problem. Farmer Ed has 3,500 meters of fencing and wants to enclose a rectangular plot that borders a river. If Farmer Ed does not fence the side along the river, what is the largest area that can be enclosed? And this problem comes with this diagram. So we can see here in the diagram that we have fencing in sort of a U shape. Only 3 sides of our rectangle are fenced in. And at the north edge, we have a river, which is in essence forming the 4th border on our plot of land. In the diagram, we are given a little bit of algebra, which makes this problem considerably easier. We are told that the north, south, east, west edge is a distance of x, the east edge is a distance of x, and therefore, by subtraction, the south edge must be the 3,500 that we started with, minus the x we used over here, and minus the x we used over here, or 3,500 minus 2x. Our job is to express the area as a function of x, and then use our equation to figure out the largest area that can be enclosed. This is actually quite easy. Area A is equal to length times width. We know both of those. So the length is equal to 3,500 minus 2w. The width is equal to x. I apologize, this should have said x. 3,500 minus 2x. Okay, now we can multiply using the distributive property. So we get 3,500x minus 2x squared. Putting this in descending order would be negative 2x squared plus 3,500x. And because we are asked to create a function, we're going to write this as a of x. All right, so now we're ready to answer the question. It says the largest area. Well, whenever you see a word, an extreme word like largest, smallest, minimum, maximum, the first thing you should think to yourself is my equation quadratic? If your equation is quadratic and you're looking for an extreme word like minimum or maximum, then you're looking for the vertex. So, is this quadratic? The answer is yes. It matches the form of a quadratic, which is ax squared plus bx plus c, where a is equal to negative 2, b is equal to 3,500, and c is equal to 0. Once we recognize that, we know that we can plug into the vertex formula in order to answer the question. So the vertex formula says opposite b over 2a, comma, c minus b squared over 4a. However, if you prefer, instead of plugging into c minus b squared over 4a, you can simply find this value for x, plug it into your equation, and that will tell you a. Since in a previous video we used c minus b squared over 4a, in this video we will simply find the x coordinate of the vertex, which will tell us x, and then plug into our equation. So I'm going to say that the vertex x is opposite b over 2a, which in this case is opposite 3,500 over 2 times negative 2. So we get negative 3,500 over negative 4. A negative divided by a negative is a positive, and 3,500 divided by 4 is equal to 875. So that tells me x. X is 875. Now a of x is equal to negative 2x squared plus 3,500x. What I want to know is a, the area. So replace all of the x's with 875. We get negative 2 times 875 squared plus 3,500 times 875. All right, order of operations says I have to do the exponent first. So 875 squared, and then multiply it by this negative 2. And this is a really big number. Negative 1,531,250 plus, then I have to do 3,500 times 875, which is also a really big number, 30625 0, 0, and then perform the subtraction, we get the result 1531250. So this is the area, and because the lengths that were given in the problem were meters, this area is in square meters. Okay, we're now done with this problem. Let's just briefly summarize the steps. The diagram made this problem very easy for us to do. We multiply this distance, the width, times this distance, the length, and that gives us an algebraic expression for a, which we write as a of x. And once it's in descending order, we're able to identify our coefficients a, b, and c. We plug a and b into the vertex x, that gives us x. We plug x into the equation, that gives us a, which is the answer to our question, 1,531,250 square meters.